Hi, I am back again from MySlate, and in this video we will move on. If you remember, we were discussing the applications of derivatives in the previous video, and we looked at the rate of change of quantities. So here we will move further and discuss another kind of applications of derivatives, which is how to find equations of tangents or normals on a curve. So let us start right away. So first we will look at the generic problem, right? And then we will look at a specific example. So I would request you to first focus on this left diagram that's shown here. So let's say that we have this curve of a given function y equals fx, and our task is to find the equation of the tangent to this curve at a given point A. And further we are required to find the equation of the normal to this curve at the same point A. And the definition of the normal is that it is perpendicular to the tangent on the curve. Now let's first talk about the tangent. Okay. Now tangent is a straight line, as you know, and you all probably already know that to find out the equation of the straight line, all you need is to know its slope and one point on the line. So let's say we already know this point A, its coordinates are x naught, y naught, so that we know. So all that we require to know is the slope. So if you know the slope of this line, so let's say the slope of the line is f prime x, and how do you find the slope of the line? Suppose you have the mathematical expression of this curve y equals fx, you could find the dy by dx from that expression, and then you find the value of that dy by dx at the specific point A, whose coordinates you know, x naught, y naught. So therefore you could find the slope of the tangent on this curve at this point A. So that's the slope, f prime x here, right? So if you know the slope and a particular point, you could find the equation of the tangent. And how did we get this equation? Well, that's quite easy. You probably already know that the slope, which we express here as f prime x, which let's say we are able to find out somehow from the equation of the curve at that particular point, that for a straight line equals y minus y naught, where y naught is the given point, that's the y coordinate of this point A here, and y we use to represent a generic, the y coordinate of the generic point. So y minus y naught divided by x minus x naught. Okay, so x naught y naught refers to the specific point that we know, and x y refers to any generic point on this line, which is a tangent. And from this we can get the equation in these terms: y equals y naught plus the slope of the tangent multiplied by x minus x naught. And remember that the slope of the tangent is found out from the equation of the curve by calculating dy by dx and then plugging in these values of x naught and y naught. And now let's look at the normal. Okay, so we already know that the normal is perpendicular to the tangent, and both the normal and the tangent, they intersect at the same point A on this curve. Now from the slope of the tangent, can we automatically find out the slope for the normal? That's given here as minus 1 by f prime x. So f prime x is the slope of the tangent. So how did we get minus 1 by f prime x as the slope of the normal? Well, probably you already know it, and in case you don't, it's quite easy. You know already that the slope of any line is nothing but the tangent, the value of the tan theta, tangent of the theta, where theta is the angle that the line makes from the positive x axis direction. That's shown here by theta. And so in our case, f prime x is nothing but the tan theta here. Now when we are looking at the normal line here, that would make a different angle, because that's theta plus 90 degrees, right? So the normal would make an angle of, let's say, theta plus 90 degrees, because that's perpendicular to the tangent, and therefore what would be the slope of the normal? Well, that would be tan of theta plus 90 degrees. And you already know probably that tan of theta plus pi by 2 equals minus cot of theta. We won't derive that here, but probably you know this already. And what's minus cot theta? Well, we know that cot theta is 1 by tan theta. So minus cot theta is minus 1 by tan theta. And that's how we get this slope of the normal. That's minus 1 by f prime theta, because f prime theta is nothing but the tan theta, the slope of the tangent. So slope of the normal would be minus 1 divided by the slope of the tangent. And that's what we plug in the equation of the straight line here to get the equation of the normal. Okay, so let's now look at this simple example here to understand how we do it. So let's say that we are giving this curve y equals fx, and the equation of the curve is y equals x cube minus 2x squared minus 1. And here I have drawn a rough sketch of the curve. It's not too accurate. But let us say that our job is to find the equation of the tangent and normal on this curve at a given point B right here, and the coordinates of the B are known, let's say. So, and they are 2 minus 1. Okay. So, x naught equals 2 and y naught equals minus 1. Well, the rest of the procedure is pretty mechanical, as we've already seen. Our first job, as I mentioned, is to find out the slope of the tangent, which is f prime x. So let's call that m here, and we are given the equation of the curve, and we know that the slope is dy by dx, which is f prime x, and let's calculate that. So what is the dy by dx of x cube minus 2x squared minus 1? Well, from our understanding of derivatives, we already know that it is 3 times x squared minus 2 multiplied by 2 multiplied by x minus 0. So we have this as a slope, 3x squared minus 4x, and we see that the slope varies at different points because it's a function of x. So and we are interested in finding the slope at this particular point B, where x equals 2 and y equals minus 1. So we plug in those values and we get the slope of the tangent to the curve at that point as 4. And we already know the coordinates of that point. So with those two pieces of information, the slope of the tangent at that point and the coordinates of that point, we get the equation of the tangent, which is a straight line. And likewise, the slope of the normal to the curve at that point, we already know normal is perpendicular to the tangent, so its slope would be minus 1 divided by the slope of the tangent, so which is minus 1 by 4. We plug that into the equation of the straight line, and we get the equation of the normal. So that seems pretty